Okay, so I started the recording, and once again, welcome to our Wednesday session. And of course, it's just to uh, bring us back to our work. We know we've all been busy with other stuff, work, family, and all that, you know, which can be somehow distracting. So the whole purpose of this session is just to keep our feet wet and continue to remind ourselves that we have a bigger project that we're involved in, which is quite a challenge, but uh, you all are capable of doing this. And I'm very confident that by the time we're done with this training, you guys will be top experts and will have a lot of value to add in the field of IT. And no matter which path you all want to take, you'll be excellent at what you guys pursue. But to get there, we'll have to be making some sacrifices like we are doing now. Jarvis waking up at 2 a.m., Fit being at work, still attending, Ola babysitting the daughters, still making that sacrifice. Jonathan, family, broken camera, but he's still making all that sacrifice. So I want to thank you guys for going against the odds to make this happen. So I will open the floor with any general question on how the studies are going, how the training is going, and if there is any concern that needs to be addressed, or if you have any question that you want to throw at me, we need any clarity on anything that you've come across that you haven't quite understand or understood, I will be able to explain and expatiate. So you guys can, the floor is open right now for you guys.
Um, Two questions from me. The first one is, so I know we're supposed to master about 32 port numbers. Unless I've missed it, have you shared that document with us so that we can start the work of cramming, because cramming takes a while.
Yeah, I will share that. I apologize, I haven't done that yet. That was because I had to correct your homework because not everybody submitted their homework on time. So I had to take time that I needed to prepare other material for class to be going through people's homework. And I can't believe that until today, some people still can't submit homework. People are still slacking me and asking me how to submit homework, which is like, come on. We have like 3 videos that have demonstrated how to submit their homework, but some people, I don't know if they are not watching the videos or they are not paying attention when we're doing it. So all that is taking time because I'll need to take time to go show you this, to go teach some people how to do this, how to do that. And again, I was also spending time to prepare your homework, which came 2 days late. It's supposed to come on Sunday or Monday morning, but I had to send it yesterday evening. But that also means extending the delivery date. So instead of you guys submitting on Friday, you submit on Sunday. But back to your question, or I will send that document to you. So it's just going to be the protocols that you need to know, their mode of transmission, and their ports. The protocol and the ports are very, very important. Like I said, there are lots of protocols, but in this class, there's just going to be some protocols that you need to know, which we'll focus on. But I promise you, I'll send that to you tomorrow.
Okay, thanks a lot, Gerald. Because I wasn't jotting those port numbers down in the videos I was watching. I was like, I'll get the document from you anyway.
Yes.
The second question I had was, so you sent out 2 YouTube videos we're supposed to watch from Professor Mesa. Right now I've paused on the first one. I'm focusing on the networking one.
Yes.
Is there going to be a time when we have to go, because I want to watch the first 15 of the first one, and I've
Mhm.
not gone past that. So that number is okay with the first one, correct?
Yeah, that number is okay for now, but hey, it never hurts to keep learning
Uh,
because
the
the,
number
the
of things
whole
I'm learning is much.
the whole idea is we are not taking the CompTIA A plus exam, so we are not going to cover everything in that Professor Mesa's video. But I've already shared it with you, and it's going to be available for you even after the class. So if you want to keep learning and become more technical, you can keep learning, right? But in this class, there are some things that you need to know for you to be able to do your job. Those are the ones that we'll focus on. So first 15 is okay for now. Now we've transitioned from computer hardware to networking, right? And we'll finish networking. And when we're done with networking, we're gonna go back to computer hardware and software. And there are some videos that Kingsley will have you watch and install a Windows server. And then we're going to set up Active Directory and group policy and how you use a Windows server at work to control all the other systems that are part of what is known as a domain. So we're going to come back to that after we finish the networking side. So the 15 is fine for now, but if you have the time to keep going, just keep going. It never hurts to add more knowledge and keep learning.
Thanks a lot, Gerard.
You're welcome.
Just this is not related to work. Have you heard from Kingsley at all? I did drop him a message, but he has not responded yet. How's he holding up?
Yeah, he's been down. He's been really down. His cousin got into a car crash. He's just 17 years old. He got into a car crash with his friends, and he's the only one who passed. And it's so sad. And Kingsley was very close to him, and Kingsley was with him. I think Kingsley was with him on Saturday, right after class. So he was with him on Saturday. And then Saturday evening, breaking Sunday, he got the news that he passed. So it's been tough for him, but he's been holding up. And I've been trying to motivate him. And I think he's going to go through this. He's going to handle it well and come back. I think he's going to be in class on Saturday. Yeah, but on Saturday, we are starting networking. So even if he's in class, he will just be a participant. Me too, I'm going to be a participant, and Charles is going to be the main tutor for the next 2 weeks. But he's good, and I think he appreciates all the messages and support you guys have been sending his way.
Okay. Thanks. That's all the questions I had.
Okay, Jarvis,
Yeah,
how the studies going? Any concerns? Anything I should help with?
uh, what I can ask for is perhaps more material to read because I've gone through what we have. And like you said, I've watched most of the videos, the first 35, and I, I welcome more material, just
I
broaden the
think
knowledge.
I think the video got more material. So both videos have about 100. I think both lessons have like 100 videos.
Yeah,
So
yeah.
if you're asking for more material, then I'll assume you've brushed through 200 videos.
No, I haven't watched. Well, I haven't watched all. Well, I'm just focusing on what you have access to watch. But are you saying that the two links you send are different lessons?
They are kind of one. The first one is CompTIA A plus, where you're
Yes.
doing hardware, software. There is some part on networking that is also intertwined in that, but
Mm-hmm.
it is just A plus, that covers hardware, software, some part of networking, and some part of security. That's A plus.
Okay.
But the security, the CompTIA security plus is, sorry, network plus is strictly networking.
All right. Okay.
Yeah. And like I said last week, networking is very, very, very important as a skill in the world of IT. It doesn't matter which avenue you decide to go to. Because at the end of this training, you can decide to be a Windows administrator, a Windows Server administrator, not a hardware administrator, right? You'll be administering servers, which means you'll not be touching hardware. Or you can decide to go into Linux and become a Linux administrator or a Linux engineer. Or you can decide to go into the cloud and become a cloud admin or a cloud engineer or a cloud associate or a cloud architect. No matter which way you decide to go, you're gonna meet networking. Networking is gonna be there. So networking is one of those prerequisites that you need to know and understand as an IT professional. It's the same like security. It's the same like security. Security is one thing that is also key. It's also key. And in all the systems that we're going to be provisioning and deploying, we're going to learn how to secure them, because you are not an administrator if you can build a system and you don't understand how to secure that system, then I don't think you'll be qualified as an administrator, right? It's just like you build a house and you don't know how to secure that house. You don't know how you can build a fence and try to do something to secure that house. You just build a house and leave the house exposed. You don't want to do that. You have to know how to not only build, but secure, right? And not only secure, but being able to communicate from within that house. So you build a server, you should be able to communicate with that server. And communicating means you're adding that server to a network, right? If you're adding your server to a network and it's not joining the network and it's having network issues, your network connection is dropping, or you are pinging the server, you cannot reach the server, or you are doing a trace set and your packets are dropping, you should be able to troubleshoot and find out exactly what is happening. You know, is it a networking issue from the OSI model physical level where it has to do with cabling? Is it a cabling issue? Is it my network interface card that is bad? Is it an IP conflict? It's my system conflicting with another system. Is it a port that is open or that is closed? Is it a firewall that is blocking traffic from coming in? You know, is it that the system is in another subnet? Is it that it has another class of IP? So has it been wrongly configured? You know, things like that. You should be able to troubleshoot these things. Was the IP address done manually or it was sent out by DHCP? Did the IP address change? Did DHCP change the IP? So you have to be thinking like that. So all this knowledge we are getting, you have to be able to apply them when it matters. So we are learning, okay, DHCP dynamically gives out IP addresses, right? And you are able to connect to a printer over the network and print. Most of us will have like wireless printers at home. And tomorrow you're trying to print from that printer and it's not printing. What will you be thinking? You go check all the connectors around the printer. Everything is connected fine. The printer indicates that it's connected to the internet. But why are you not printing? It's not a paper jam. So what is causing that problem? Then you should start applying the knowledge. You know, okay, this printer was configured to get an IP address from DHCP. So maybe DHCP has changed that IP address because I did not give this printer a static IP. I gave it a dynamic IP, which means maybe the lease period expired and DHCP took that IP away and assigned a different IP. and you're trying to use the old IP to connect to that server to print, it's not going to print. That's how you need to be thinking. So there's a lot, but it's all about taking the knowledge and try to apply it and think proactively, because we'll learn all these things. I'll teach you all the troubleshooting techniques and formats, but I cannot teach you everything, because at work you'll be faced with different problems, but you have the knowledge to be able to use that knowledge and say, okay, based on my knowledge, I think this is the problem or that is the problem.
Yeah, I think that as you have said, the most why we didn't I think the most interesting or challenging thing is we should often think about is, all right, I've read this, but how is it going to be applied? So just to that, can I ask you how, for example, you're at work today, what were the typical things you came across which may be useful for us in this lesson?
I didn't do any networking stuff today at work, but yesterday I was working with the firewall, and I know I spoke briefly about a firewall in the last lesson. So what if a firewall could be a hardware or a software? It could be a hardware device or it could be software. And the work of a firewall is just putting together a set of rules that determine how network traffic gets in and out of your network. So you can come up with a rule that says you don't want SSH traffic into that network, or you want to block HTTPS traffic. HTTPS traffic will not come into that network. And the way the firewall rules are set, it affects incoming. You have a rule that you can set a rule for incoming traffic, and you can also set a rule for outgoing traffic. How is traffic leaving your network? So it's like a security guy that decides, like, okay, who comes in and out of this house? That is typically what a firewall does. And within your Windows machine, within your laptop, there is an inbuilt firewall on your Windows machine known as Windows Defender. On a Linux machine, the Linux firewall is known as Firewall D. And firewalls are very important. So that is the software firewall at the level of your machine, which you need to configure. There is also a network firewall that sits at the edge of your network, right? So at work, you also have a physical device, which is known as a firewall. Let me show you what a firewall looks like. Okay. Yeah, so the devices, firewalls are gonna look like this, so, and they are quite expensive too. Look at this one, it's like almost $900. This is Fortinet, this is Sonic Wall. I work a lot. We have this one at work, the Sonic Wall. So in an interview, they can ask you your experience with firewalls and what kind of firewall have you worked with. You should be able to say you've worked with a Sonic Wall TZ400. If you just say a Sonic Wall or you just say firewall, they will know that you're probably not telling the truth, right? You should be able to tell the specific firewall that you've worked with. This is an example. I've worked with this one. I've worked with it with a Sonic Wall, but it's not the TZ400. There are lots of different models of Sonic Wall, right? Sonic Wall is like the generic name, but it has like different series and different categories. So even if you've never worked with a Sonic Wall firewall, you can go to YouTube and just watch a video of how you can use a Sonic Wall firewall to protect traffic, or to configure a Sonic Wall firewall to prevent traffic going in and out of your network, But At home, you do have an inbuilt firewall in your router. So your router at home plays a couple of roles, right? Your router routes traffic. So when the connection leaves the modem and comes to the router, the modem I told you last week, the modem will transmit or transform analog signal into digital signal. Your router does not understand analog signal. Analog signal comes from your ISP. So the modem will take the analog signal, transform it into digital signal that your router will understand. And then your router will take that signal and then broadcast it to your local area network, your LAN. And your router can be a wireless router or it can be a wired router. If it's a wireless router, then you'll be able to connect wirelessly by putting the Wi-Fi name and password. But most router will have both capabilities. You can also use your wired connection, use your RJ45 cable or your CAT cable, plug to the router, and then you plug to your machine, or you plug to the router and then plug to a switch, and then plug to multiple devices. So that's one thing the router does. A router also does firewalling. It's also a firewall. You can go into your router and configure your router to block certain type of traffic and allow certain type of traffic, to block certain type of ports and open certain types of ports. So your router is also a firewall. Your router also does something called DMZ. We'll cover that. You guys are going to cover that with Charles detailedly. And of course, I told you last week, at home, your router is also a DHCP server and it's also a DNS server. So the router you have at home is doing a lot of different stuff. But at work, you're going to have a separate device like this. You have more, 2 or 3 of them, depending on the size of the company. So you're going to have a separate device that is a firewall. You're going to have a separate device that is a DHCP server. It's going to probably be some computer sitting somewhere. You're going to have another separate device, a separate computer that is a DNS server, and then your router will just do routing, will just route internet traffic. Then they're going to combine it as the router that you have at home. So this is an example of a firewall. So a firewall, like I said, it's just a set of rules. You log into you can plug a USB in here. So the firewall is a computer itself. This device is a computer device. It acts like any normal computer. You can actually plug in a USB here for a monitor, right? And there is another plug in the back where you can plug in your keyboard and be able to work with the router. It has an interface where you can log into the interface and actually configure the router to do what you want it to do. So that is just one. There are many different types of routers. This is another one here. This is Fortinet 90E. So there are different types of routers. So you can do more research on this, but we're going to cover this. Charles is going to cover routers and go into more details than I have told you so far. So that's what routers do. So any other question, Jarvis?
Yeah, I had a little bit of concern about switching.
Switches.
Yes, how it actually works in the working environment.
Okay. Okay, so a network switch.
Yeah.
So a network switch is going to look like this. It looks almost the same as a router, but it looks almost the same as a firewall, but it's not a firewall, right? A switch, all a switch does is connect multiple devices together. This is an example of a switch. Look at how expensive this one is. So a switch will have like about between 20 to 50 different ports. And in a work environment, you have all these ports will be filled with CAT cables or Ethernet cables that are being directed to different machines. So if you go to work and you see the internet jack on the wall where you just plug the internet cable, and you plug on your machine, that plug on the wall is actually wired to a switch. So the work of a switch is just to connect devices together. So the router plugs into the switch and it brings the internet connection to the switch. And then any other device can now connect to the switch and get internet through a wired connection. Switches don't do wireless. Take note of that. Switches don't do wireless connection. They don't do Wi-Fi. Switches is just with wired connections. So if I'm to demonstrate how a network will look like, where is our Slack? Oh, should I do that? So let me go to the whiteboard. So just give me a moment to select, and let me find. Okay, so let me use this as an example. So let's do this, and no, let me erase. Undo. Take the blue. Take this one. Blue. Okay. So I'm gonna do this. So this right here just represent like the internet, right? And then I'll do this. Let's say you have two devices. So one device is gonna be your modem, and then the second device is gonna be a router. And then right here, you're gonna have your switch. This is gonna be a switch. And then, so like I said, the switch is gonna have multiple ports on the switch, multiple ports to connect the devices. And then we can have another device here known as your access point. And then here you're gonna have your laptops, your desktops, you know, maybe phones. Guys, permit my drawing. I'm not a good artist. You're gonna have your iPads. So these ones are gonna be your devices. So let me do some labeling. So here is gonna be the internet. And then here is gonna be your modem. Here is going to be a router. And then here is going to be a switch. Here is going to be your access point. And then this one right here is going to be your devices. So laptops, desktops, tablets, etc. So this is typically how a local area network is going to be, a LAN, right? So this is the internet. So I forgot one thing. So let's do no, let's do internet plus ISP. Okay. Now, so this is how your LAN is going to be. You have your internet and you have the ISP. And like I said, the internet, anything out of your LAN, let's go back here. Anything out of your LAN is the wide area network. So all of this is going to be your LAN. This is your LAN right here. So the internet and your ISP, they are not part of your LAN, right? So in here, this is your LAN, your local area network. Out here is the wide area network. So this is the WAN, this is your LAN. The internet and your ISP, they are the wide area network. You call your ISP, say Comcast, and you want to sign up, and you sign up. They're gonna give you a modem, or they're gonna give you a router. They're gonna give you a modem, or they're gonna give you a router. Or they're gonna give you one device that is a combination of modem and router, right? If you have two devices, then you can check. You'll find out your router is connected to the modem. If you have one device, sorry, that is a modem and router combo, then there's not gonna be any connection. But if you have two, one is gonna be the modem. The modem is the one that brings the connection from your ISP into your LAN. And it brings the internet connection with analog signals. Your router does not understand analog signal. So the modem will convert the analog into digital signal and send it to the router. So there's a connection here between the router and the modem. And you can also have a wireless router, or your router is gonna do both wired and wireless functionality, right? So it will send wireless signals, and it's gonna have wired capability. So which means there's gonna be a connection. So there's a connection between the router and the modem here. Then there is another wired connection with your network cable or the Ethernet cable or the RJ45 cable between the router and the switch, one of the ports in the switch. This connection is going to be there. So the router will take the internet connection or the digital signal from the modem, and is going to extend it to the switch. The router is also going to have wireless capabilities. So it's going to be able to send wireless signals in the form of radio waves. Like I told you, Wi-Fi is transmitted through radio waves. So it's going to be sending all these radio waves for any devices in this network to connect to Wi-Fi wirelessly. So these are your devices. Some devices will connect to the internet via wireless. Some device will connect with the wired connection, and all the wired connections will go to the switch. Go to the switch. Go to the switch. And then maybe this other guy here is connecting through a wire, through Wi-Fi, to the wireless connection. And we have an access point. Access point will connect directly to the router, direct connection. And the job of the access point is to extend the Wi-Fi connection. Let's say your wireless router, the wireless signal stops somewhere here. Devices in this part of the office are not getting the wireless connection. How are you going to extend it? You will need an access point. It's just a small device. Let me show you what it looks like, a router, but it's not a router. Yeah, this one an access point looks like. You know. Yep, so these are access points. See, and if you look at this image right here, you're gonna see the wireless router connecting to an access point and then extending the wireless signal. So this computer can connect to it. So that's what an access point does. And yeah, and that is typically how your network is gonna be at work.
I have a question.
Yes.
So, like the metropolitan area network is just inside the one country, or can go out?
It's inside a metropolis. And a metropolis could be a small town, it could be a city.
Cannot go like out of the country, right? Cannot, it's not larger than that one.
Out of the country is the wide area network.
Okay.
And metropolitan area is a network that covers a metropolis. So think of it like a TV station, a cable network that is providing cable services within a city. That is the limit of a metropolitan area network.
Like banks too.
Yeah, if you want to go out of that city, then it becomes a wide area network, because you are trying to extend the capability.
Okay.
Yeah, so guys, this is a typical example of how a local area network will be. And within a local area network, guys, you have two ways you can connect your devices. You can have a pair-to-pair network, which we talked about last week. And you can have, what else? What is the other one? Who can remember? You can have a client server network. These are the two, right? You can have a pair-to-pair network within your local area network, or you can have a client server network. A pair-to-pair network means there is no router. These devices in the network, they are not connected to a server, sorry. There is no server involved, right? So you can have this laptop connected to this laptop connected to this one connected to this one. So all these devices here They are interconnected with each other and sharing information with each other, but there is no server involved. That is a peer-to-peer network. One device is paired to the other one is paired to the other. That is a peer-to-peer network. So you can decide to do that. A peer-to-peer network is a typical example of what you have in your house. In your house, there is no server, right? Your devices, you can connect two laptops together at home. You can connect your laptop to a TV. That is an example of a peer-to-peer. There is no server involved. But at work, you mostly find a client-server network where you have all these devices connected to a server. Let's say the server is here. So all these devices will connect to the server to get some kind of information. Let's say you have, let's say this is a print server and you have a printer at work that everyone uses that printer to print, right? So you have a print server that manages print requests. So Ola sends a print request, Jarvis sends a print request, Jonathan sends a print request. We all send a print request at the same time. The printer cannot just be printing randomly. Something needs to manage the way the print requests come in and allocate every request in some order. So you have a print server. So all our print requests will go to the print server, and then the print server will send the request to the printer in order. Say Jarvis first, and then it prints your stuff. And then Bama first, it prints Bama stuff. Ola next, just like that. So this is just an example of how a client-server network will be. So you have a server in the middle, and then all these clients sending their requests to the server to do some printing. Otherwise, think of a printer having like 100 print requests from 100 different people with no server to control it. And all of us are waiting for a printer to print out our stuff.
That's
You don't
good.
know whether yours went to the server before mine. Who is controlling that? The server is gonna grow mad, right?
That's been, this is gonna centralize all the information.
Yes, it's gonna take the request that is coming from the client
Okay.
and manage it in such a way that this there's not gonna be any jam, no confusion, easy management, and it's not gonna overwhelm the printer.
Okay.
So when your print request comes, it's gonna be put in the queue. And when it's your turn to print, the server is gonna send it to the printer to print. Yeah, so this is a typical example of how a local area network will be. But like I said, a peer-to-peer is an example of what you have at home. But the client server is what you see in most workplaces. Question? No question. Okay. Now, I also want to talk to you.
I have a question.
Yes, go ahead.
So my question is not related to this one. It's, I sent you a message. I don't know if you saw it.
Yes, you sent a message about submitting your homework, and I said we've gone over that like 1,000 times.
Yeah, you're right. But because even my phone, I don't know, because they say on my phone that the cloud is full.
No,
So that's,
I said go to your email address, open your email address. When you go to your Gmail, sign up to your Gmail, put your username and password, and when you're in your Gmail, let me go to mine and show you again. You click right here on the Google Apps, go all the way down to Google Docs. That is it. On Google Docs, you open a blank page. Give it a title right here. Title it Assignment 1 or Homework 1. And then you go to the homework, copy the questions, and you paste it in here. answer the questions. When you finish answering the question, you click on share, and then you put the text space email address in here, which is techspace500@gmail.com.
Text space.
This is it, techspace500@gmail.com.
Okay.
You put in the address here. That's who you are sharing with, right? So
Yeah.
after doing that, make sure I have editor privileges. So if you don't give me edit privileges, I will not be able to edit your work.
Because asking me like to request.
Now it's telling you editors can.
Yeah, I saw that one.
Yeah, so that is it. Once you do that, I'll be able to see the homework.
Okay.
Simple as that.
Okay.
Yeah.
Thank you.
You're welcome.
Mm.
So I also wanted to share this with you. Bama, who's your ISP?
Talking to me?
Yes.
What
Who's
is it?
your ISP?
The ISP?
Yes.
It's Fox.
No, who are you getting internet from?
Yeah, Fox.
What do you mean Fox?
Fox.
The company is known as Fox?
It's Cox, yes.
Oh, Cox.
Cox.
Okay, Cox, yeah, I've heard about Cox. I heard Fox.
Yeah.
Ola, what about you?
Ireland has it.
Yeah, I've heard about Cox. I've heard about it.
Exactly.
Ola, are you there?
Yep, Spectrum.
Spectrum, good. Jonathan, who's your ISP?
Comcast, Xfinity.
Okay. Bertrand, who's your ISP? If you cannot talk, you can just type the answer. Faith, if you can hear me and you can type, just go ahead and tell me who your ISP is. And the last person who connected with the phone, I don't know who the person is because there's no name. Go ahead and tell me your ISP too. Okay, Faith is Comcast. Okay. So the reason I'm doing this is because, okay, Spectrum. All right. Now, most ISPs, when you sign up for internet and cable with an ISP and you're paying your bill every month, most ISPs are supposed to provide you with an antivirus as part of that package. A lot of clients don't know that because I know Faith did say she wanted to get an antivirus for her machine. And the message I have for you today is, if you have Comcast or Xfinity, most of those ISPs provide an antivirus for you for free because you've signed up for their service. Let's take Comcast, for example. So let's do Comcast antivirus, right? See, and our Xfinity internet customers who lease X5 gateway already receive seamless, innovative digital security protection through this. So it's Norton free for Comcast. Let's click that. Available at no extra cost for Xfinity internet customers. So call your ISP and tell them you're supposed to be getting an antivirus free. It comes with your bill. That's what you pay for every month, and most of us don't know that. Those who are using Spectrum, call Spectrum. Those who are using Xfinity, call Xfinity. Your antivirus is Norton. Your agent is going to install it on your machine, and you're not going to pay for anything. So take note of that, guys, and tomorrow call your ISP if you don't have an antivirus, because you're already paying for it without knowing. Any question?
I wanted to ask you about how this, for example, looking at this IPv4 addresses. I read about some mathematical operations, how to come up with the addresses. So how can we use that in the working environment? This mathematical calculation. So
Charles is going to cover that, because if that's an extensive topic, if I start tonight, we're not going to finish. But what I can tell you is that at work, you're not going to be doing any, you're not going to be doing those calculations. You can come across a situation where you're doing subnetting, and you have to do some configuration to do subnetting in your network. But before doing that subnet, you have to understand and know the amount of subnets that is required, that you want to provision, right? So in a case like that, there is always a subnet calculator that you can use, because if you want to do it yourself, it's not easy. So there are always subnet calculators online that you can go use to do those subnet calculations. So if you just Google subnet calculator, it's already popping out. You see IP subnet calculator. Each time you guys are doing subnetting, you come use one of these subnet calculators. And yeah, depending on if you are doing a class A network or class B or class C, you know, you just put in it here, you put in the subnet, decide on the slash, if it's a /24 or a /23 or /22, depending on the number of hosts that you want in that network, you just select it here, and then it's gonna, this subnet calculator will calculate everything for you, and you just take the figures and go apply it. You know, so this subnet calculators make things easier. All those complicated calculations you won't do, you just know, okay, this is the amount of hosts I want, and then you come and you choose it right here. If I want 100 hosts or 1,000 hosts, you come select it from here, depending on the slash, you know, and then you do calculate. It's gonna give you the answer, and then you gotta know what to do. But normally you won't do that. Mostly the network administrators will do that. You are a server admin, you are not a network admin. You are not required to do that, but you are required to understand the process. But Charles is going to take you guys extensively into all this network subnet calculating and all that. Any other question? Should I ask my own question since nobody's answering? Somebody is coming to class when class is ending. So I said, should I ask my own question? And everybody is quiet. Ask me a question, everyone is quiet. So what should Ola, should I ask my own question? Since you guys don't have questions.
Yes, sir.
Yes, no problem.
Okay, so
I have a question.
yes, what's your question, sir?
Please,
It should be a networking question because we are doing networking.
The difference between a router and a switch.
I just explained that, so you have to go watch the video. I cannot go into it again, but I did a wonderful explanation. But is there anyone who didn't understand? Like, it's also very straightforward. I shared with you this document on Slack, and I think I shared with everybody this document right here. If you look at it, it clearly tells you what a router is and what a switch is. You know, this is it. You know, a router is used to connect different networks together or network devices. You know, you can also use a router to connect different LANs. So to connect my local area network with your local area network, Bismarck, there's going to be a router in between my network and your network. So for our two networks to talk to each other, we do need a router. That is what a router does.
Okay, thank you.
So it connects two different networks together. And within a network, you can use a router to connect, to send internet signal to the devices in your network. And if you come right here, you're gonna see a switch, which is used to connect different devices in the network. So you have a central switch, you connect the switch to a router, the router provides internet connection to the switch, and then everything else connects to the switch. So you can have one switch that is connecting like 50 different devices. But again, take note, switches don't send out wireless signals. They are wired connection. Okay. Okay, so so make sure you go through this document. You know, everything I explained today, we have here well explained. And let me just briefly touch, I think it's even time. Let me just briefly talk about the structure of an IP address. So like I said, focus for now on IPv4. And an IPv4 address is a unique 32-bit number, or you can say it's a 4-octet number. And
IPv.
So this is going to be the structure, x.x.x.x, where x equal to number. And like I said, it is a unique 32-bit number. So every x here represents 8-bit. So 8888 equals to 32. That is why an IPv4 is a 32-bit number. Or you can say it's a 4-octet number. Every x here is going to represent 1 octet. And if you add all the octets together, it's going to be 4. Right? And what you should know about IPs is that it's a 12-digit number. It cannot be more than 12. So 3333. It cannot be more than 12. Right? At most, it should be a 12-digit number separated by the colon. So here you can have 3. You cannot have more than 3. It should be 3333. You know. So it cannot be 4, 2 or something. There are cases where you can have 2 digits here or even 1 digit. You can have 1.1.1.1. But the point is you cannot have more than 3 numbers here. You cannot have more than 3 numbers here. You cannot have more than 3 numbers here. And the numbers here cannot go above 250. Any number you put here cannot go more than 250. So this can be 200.200.200.200, right? So each octet cannot go above 250. Sorry, I said 200. 255. Sorry, I said 250. So it cannot go more than 255. So you can have 200.200.200.200, or you can have 1.1.1.1. But you cannot have 1.300.400.500. No, it cannot work. And you can also ask me, how are the numbers assigned? Are the numbers just given randomly? No, there is an order to it. IPs are given according to classes. IP addresses are given according to classes. So let me go down here. If you look at this document, you see IPv4 classes. So by looking at an IP address, you can tell the class that that IP address belongs to. Class A IP addresses will belong to this class. So if you check your IP and you see 10.0.0. something, you know that is a class A IP address. And it will always follow this format. If you see a class B IP, it will start from 128.16. So look at the octet. So class A IPs will start from 0, or from 1, sorry, all the way to 126. And this is an example, 10.0 dot something dot something. I just give an example here, .1.1. Class B IP addresses will always start from 128 all the way to 191. This is an example, 128.16. Class C will start from 192 and go all the way to 223. And this is an example, 192.168. So it will always be 192.168 for class C IPs. For class B, it will always be 128.16. The last octets will change depending on the devices. And class A will always be 10, 10.0, and then the last two will be depending on the subnet and the device that is being allocated to. So it will always be in this format. And you can ask me, okay, this started from 1 to 126. Why is it not started? Why is class B not starting from 127? Did you guys notice that? So class A from 1 to 126, and then it skipped 127 and went to 128 and started assigning from 128.16. Why is 127 left out? So 127 is known as a loopback address. So 127, come on. You see, 127.0.0.1 IP. It is known as the loopback address or the loopback internet protocol. And it is reserved. That is an IP address that is reserved. It will never be assigned to any device in the network. So 127.0.0.1 is used for troubleshooting what is known as your IP stack. If you have a defective IP stack and you ping 127.0.0.1 and you don't get a response, it means your IP stack is defective. So you can try pinging this address, 127.0.0.1. You're gonna get a response. It's gonna respond to you. If it doesn't respond, then your IP stack has a big problem, and you will need some serious network configuration to fix that. So 127.0.0.1 is not assigned. No router will assign 127.0.0.1 to any device. And that is why it skips and goes to 128 here. So you have to study and know your IP classes. The class A, class B, and class C. Don't worry about class D and class E, because the US government and the US military, they use class C and class D. And that is why you see an example right here for a class E is not available. That's what the CIA is a class of IP address that's used by the CIA, the FBI. You never see it on any device. You know, even the class D, you see the subnet mask is not available. It's used by the military. So your focus should be class A, class B, and class C. Know their first octets and their last octets. Class A will go from 1 to 126. Class B, 128 to 191. Class C, 192 to 223. And these are examples. So if you check your IP address right now, and it's giving you 196.168, say .5.20, you already know that is a class C IP address. If you check your IP and it's giving you 10.0.0. something, you know it's a class A IP address. So go ahead and check your IP addresses right now and tell me which class your IP falls within. Go ahead and do that. You all know how to check your IP address, right?
Yes, sir.
Yeah, go ahead.
I have IPv4 address 192.168.28.141.
So which tells you what is your IPv4 class?
Class B.
That is a class C IP.
Class C.
I feel it.
Yeah. Who else? Who else will check their IPs?
I have a class C.
Okay, wonderful. Who else? Jonathan. Ola.
Right now, I have a class A actually. We are checking the external IP address, correct? The public IP address.
No,
The
we are
internal
dealing
one.
with, we are not, I remember I told you, you don't have anything to do with your external IP.
Then I have a class C.
Yes, so you don't have anything to do with your external IP. Remember, there are two types of IPs. Your public IP or your external IP, which is the IP that your network uses to communicate with the internet. You don't have any control over that IP address.
Yeah, that one is your secure. That's your default gateway. It's called your default gateway, and you don't have no control on that. I also have a class A IP.
Yeah. So that is it. So, and I told you guys, if you want to check your external IP, you just go to Google and you just type, what is my IP? It's going to tell you, this is my IP, this is my external IP, this is your public IP, this is what, that is the IP that is routable on the internet. You have no control over this IP. That is your publicly routable IP. But your internal IPs, the IP address that is assigned to machines in your network are internal IPs. Those are the IPs that you can change. Those are the IPs that you can assign to a device. Those are the IPs that devices within your local area network need to be able to talk to each other. But if you're talking to a device out of your network, out of your local area network, you are using your public IP or your external IP. And what makes that possible? I explained that last class. What makes a device within a local area network to be able to talk to any device in the internet using their public IP? How does that happen? I was able to explain that to you in the last session. Something makes that possible. What is it?
Is it NAT, N-A-T?
Excellent. Wonderful. Smart. Network address translation. That is the answer. If you don't understand it, go revise it. Network address translation. So let me show you one more thing on this document. I want you to look at, so this is an example of an IP address, 192.168.5.2. An IP address is divided, it has two portions. You have the network portion of the IP address, and then you have the host portion of the IP address. So the first 3 octets of the IP address are the network portion of the IP address. So in this example, 192.168.5, that is the network portion of the IP address. And then the last octet, the .2, represents the host portion of the IP address. So like I was explaining to Jonathan last week. So if you add another device to this network, let's say this is the last address that DHCP assigned, this one with a .5. The next address, the next host that joins this network and connects to this network, DHCP will probably assign it a .5, a .6, or a .7. And as more hosts continue to join the network, DHCP will continue to give the host different IPs based on the host portion. But the network portion will never change. The network portion will remain the same. So this part, 192.168.5, That is your network portion of the IP address. It will never change. But the host portion will continue to change depending on the number of hosts that are leaving and joining your network. Does that make sense? So if I have 10 different devices, I'll have 192.168.5. Let's say DHCP started assigning from .5, because you don't want DHCP to start assigning from .0. No way. You always want to give room. So most networks will be configured to say, to allow room for DHCP to start assigning IPs from say .5 or maybe .10. So you can see 192.168.5.5. So the first 5 hosts are reserved for internal use and for troubleshooting. So you add the next device is going to be .6, next device .7, next device with .8. So the host portion will continue changing based on the devices that are being added and leaving the network. But the network portion of the IP address is static. It will not change. You have to understand that. That is very, very important. I hope I'm clear with that.
But I am confused a little, sir.
Yes, why are you confused?
When I Google search what's my IP, I get a class A.
You cannot get a class A when you do
I have
what's my IP.
24.244.102.157, which of course is a public IP that the other lecturer says it is my default gateway.
No, your default gateway is the IP address of your router. Remember,
Yeah,
your
that is
router
yeah.
is also a device, right? That's what he's trying to explain to you. Your router is also a device in your network. Your router also needs an IP address. You understand that? It's a
Okay.
device like a computer in your network.
So the thing is that if you do CMD, right, Bismarck, if you
Yes,
do
sir.
CMD, if you go to IP config, you hit enter, it's gonna come up with your IP address, which is the IPv4. Let Gerard do it. You see what I'm talking about. He's gonna show you. Just do IP config. Yeah, that's it. No, don't do all. Don't do all. Oh,
Okay.
yeah, you did all. Yeah, just do IP config. So you see, if you see where it says default gateway,
Yes, sir.
that is the IP address of your router.
Your router.
So that IP address, if you don't have that IP address, you can never get internet access on your computer or on any of your other devices.
Yeah.
Because this is what gives you, it's like a bridge. It's like a bridge between your internet and your devices in your home.
Yeah.
So that's what gives you internet access. Then the IPv4 is the one that's on your computer. That's your computer IP address.
Exactly. So this is the IP address of my laptop, of my
Yes.
device. This one right here. Default gateway is the IP address of my router. My router is around the corner, right? Any traffic that goes in and out of your network must pass through your default gateway. So if you don't have a default gateway address, there is no default gateway. Traffic cannot leave your network and it cannot come into your network. I hope that is understood. However, when traffic leaves your network to communicate with any device on the internet, it doesn't use your default gateway address. It uses your external IP address, which is this one. This is my external IP. Yours is going to be different. So the traffic will go through your default gateway and then grab your external IP. And that is made possible through network address translation. To go to the internet and search, for example, if you're searching a web page, whatever you're searching for the internet, it will be routable using your public IP. And when that comes back into your network, it goes through your default gateway, goes through NAT, and then goes to the device that you use to request something from the internet. That's how it works. I hope that is clear.
Thank you. Yes, sir.
Any other question? We're about to end. We have like 5 more minutes and we'll be out of here. Okay, let me ask my own question since nobody is asking a question. So, Jarvis, what explain what you understand by DHCP. You're muted. Unmute. Jarvis, are you reading or you are doing some research to answer the question?
No, I was not. I had minimized my screen. So
why are you minimizing your screen? You're not supposed to be looking at your screen. Just tell me what DHCP is.
No, it's because I'm typing. It's because I'm typing.
Okay, go ahead.
The lesson. Yeah.
I'm just messing with you.
DHCP is a dynamic host configuration net protocol, and it's used in local network protocols to connect server requests, kind of using the IPs.
Are you sure about that answer?
It's
okay. Bismarck, put down the phone and tell me what DHCP is. You are muted. Unmute yourself.
Yeah, I've done that.
Yeah.
By DHCP imply the dynamic host configuration protocol. It is dynamic host configuration protocol is assigned when it is a DHCP that automatically assigns the IP, and we have to turn DHCP to automatic so that each time we twin on, we go to the network, the DHCP automatically configures the IP to the machine when we.
Okay, good try, but my problem with your answer is language.
You want me to answer?
Yeah, Kingsley, you are an expert in DHCP, so
DHCP.
I can take a guess.
DHCP is a dynamic host configuration IP. It assigns IP address to every computers. That's just the basic definition of DHCP. What it does is assigns dynamic. When it says dynamic IP address, with the meaning of dynamic, it means if, as Gerard said in last class, even though I was not there, but I watched the video, he said in last class, like when it assigns an IP to your computer, once you turn on that IP on the network, once you shut off that computer, and next time you turn on that computer again, you're not still gonna have the same IP address that you had before. If you want, after class, you can try it. If you shut off if you take the IP address of your computer, you turn off your computer and turn it back on, you see that the last 3 digits of your IP address has changed. Because that's been done by DHCP. DHCP is the one that sends you a new IP address, because immediately as you turn off your computer, that IP address that you had on your computer is assigned to a different device that is open. So it has a range, it has a varieties of IP address that it assigns to each computer. And then your network has a specific amount. That's why you see big networks, they usually buy extra more DHCP IP addresses, new IP addresses to extend the amount of capacity for the companies. And if you understand, there's enterprise DHCP IP addresses, and then you have a regular local DHCP IP addresses that's been assigned, which is the one that he just showed earlier, from 1 to 26. That you can have in your local network. That is doable. But when you start going out to like enterprise and big companies with like a capacity of like maybe say 1,000 plus, they have a different varieties of IP addresses that goes to almost like 1,000. And for you to get that amount, you need to pay extra for it, for them to assign you, to give you more DHCP IP address. And you need to pay more extra. So that's why you see companies are very skeptical when you don't. Their network is very tight in the sense that you don't bring outside laptops or outside electronics into the company. if they don't allow it.
Yeah, because think of a situation where you are the DHCP scope of your company is 250 IPs, and they already have maybe 250 devices, and you have like 10 people that took their devices home, and that those IPs on those machines got released, right? And then I bring my laptop at work and bring 2 extra devices at work, and then those 10 people come to work too, and we have just 10 IPs left to be assigned by DHCP, but we have like 12 devices. What's going to happen? It means some people's machines will not be able to connect to the internet.
You have what they call IP conflict.
Yeah. So
that's called in a technical term, it's called IP conflict. That means, that being said, you have some people, somebody's gonna have internet for like, let's say 2 minutes, and then it goes off. The other person has internet for 2 minutes, then it goes off. This person has back internet. That means it's just kind of like fighting, jumping from one person to another. It's trying to assign it, but it's confused because now it has minimal IP addresses. That's why I see companies usually buy extra, like maybe say plus maybe 50 or extra 10, just in case they have visitors from different offices that wants to connect their devices on their network. And it has to be a company device, because most companies, they usually set their IP address to statics. So even if, like as Gerard said, some companies will set to static, some companies will set to dynamic, because they have more. The ones that set to dynamic is the ones that have more IP addresses to share in the IP scope. But the ones that set to static is the ones that have minimal IP addresses. So they set everybody's computer in the company to a static IP address that even if you take that computer to a different network, your IP address is still going to be unique. It's not going to change.
yeah.
And when somebody else now comes into the company with let's say, let me call it a foreign device, because now it's not part of the company device. Now with that extra IP that they have, which was minimal, is going to assign one IP to the person. And when the person leaves, the IP stays back into the IP scope. When next person comes, it might assign it to a different device. That's just how it is. But with a dynamic company, a company that has like dynamic IP addresses, they don't care. They don't set that their devices to static. You can have a dynamic IP on your address today. You go home, come back tomorrow with that device, you have a different IP. That's just like big corporations that they have, like, they have money to keep buying more IP addresses. But smaller companies of like, let's say 1,000 less plus sizes, they'll always want to stay with like static IP addresses, because they want to assign each machine with a specific IP address that even if you get off the network, your IP address stays unique. It doesn't change. And we're going to get into static IP addresses at some point, so you guys will understand.
So remember, your take home today, remember, your public IP is used in the wide area network, which is the internet. Your local IP is used in the local area network, the LAN, which is within your house. So external or public IP is used in the WAN, and the internal IP is used in the LAN. You have to know that. Another thing you need to know, there are some devices at work that must have static IPs. Who can give me an example of a device at work that must have a static IP?
I think a server.
A server
Yes,
is a good
that's one.
example. Jonathan.
A router.
A router, that is correct.
A printer.
A printer. Can you explain to me why a printer should have a static IP address?
Because get the information and send the information out to.
Good try. Who can come up with a better explanation why a printer should have a static IP? Bismarck.
I can try.
Yes, go ahead, Jarvis. Why should the printer have a static IP?
I think that if it's if the IP of the computer is dynamic, it will change frequently, and every time you have to print, you will have to reconfigure. You will try to connect it several times. But if it's static, it's just whenever you send your print command, it will be the same. So once it's connected at the workplace, you always do it. But if it's dynamic, it will be changing frequently, and each time you come over, you have to configure
And
it.
actually, the short answer to that is just that the printer is because it's a shared device.
Okay.
The printer is shared in the company network,
Yes.
so you don't want to change. You don't want to make the printer a dynamic. But your answer is correct, Jarvis. It's just that the way I'm making it shorter. It's just that it's called a shared device in the network because why? Everybody needs to print from that device, and if you put a dynamic IP there, as you said earlier, everybody will need to keep configuring the devices to print on that printer. And you need to keep adding that printer on your laptop to print it because the IP is not static. But if it's a static IP, once you add the printer to your device, it stays there forever.
Yeah, exactly.
So, yeah.
You remember we spoke about peer-to-peer network and client-server network.
Yep.
Right. So think of that printer like, say, a server. I just explained to you earlier that all print requests will go to a server. That server has a static IP. The printer too needs to have a static IP because if the IP address of that printer changes, then people will not be able to print because they have a former IP address for the printer and they are sending all the print requests to that IP. The IP is not found in the network anymore because it's changed. No one will be able to print. So when you're using shared resources in a network like a printer, the IP address should be static. And I told you, when you're assigning IPs, you can do it dynamically using DHCP, or you can do it manually by configuring it yourself as the admin. And I showed you last week how to go to your network interface card, to your NIC, and set up a static IP. I showed you guys how to do it last week. So at work, devices that you'll be doing static configurations, you, the admin, you need to go and manually configure that device for static IP. That is it, and that's where we'll end today, unless there is any other question.
Yes, sir. Yes, sir.
Yes, you have a question you ask.
Please, I just need one more light on the difference between public IP and default gateway. Reason being that there's an issue here that I wanted to try, but if I don't see get the points clear, I'll not be able to adjust it on my network.
Your network was breaking. I don't know if you want to fix your
Bismarck, your
connection.
network was breaking so bad we could barely hear what you said. But I heard default gateway, I heard public IP, and
I think he's trying to ask the difference between a public IP and a default gateway.
is that what you're asking, Bismarck?
Yes, sir, yes, that's what I'm asking.
Okay, the difference between the public IP and the default gateway.
Oh, let me see if you can answer. You want me to answer that?
So yeah, you can take it, Kingsley.
Can somebody try, or anybody can try? Let's try first.
Who can try? I've explained it like 2 or 3 times already. Who can give it a shot?
A default gateway allows communication with your router, and your public IP is what allows you to when you communicate with the internet. And it's this change is done with the help of NAT. So when you connect with you first connect with your router, and then want to connect with the internet, there's some network translation, address translation with the help of NAT that gives you the public IP to connect on the internet.
Okay, so the simple and short answer is your public IP is publicly routable in the internet, right? Private IPs are not. You cannot route a private IP over the internet. So your public IPs or external IPs are routable over the internet. Your default gateway is an internal IP. It's not an external IP. That's what you need to understand. And it is the IP address of your router. And the default gateway itself is a gateway for information to go in and out of your network. But the IP address itself of the default gateway IP itself is the IP address of your router. And it is an internal IP. You cannot route traffic to the internet with an internal IP address. I've said that multiple times. So I hope that distinction is very clear. All right.
Thank you very much.
Okay, guys. So Saturday, Charles is going to take over for the next 2 weeks, and he's going to take networking to another level. So I want you guys to catch up already with all the hints I'm giving you, because he's going to take networking intensively. He's going to take it to another level. He's going to go deep. So it is very vital that you start understanding some of these concepts and actually be studying if you haven't had time to be doing that. I posted the homework yesterday, and I hope you guys have seen it. And it is due on Sunday before class. You should submit your homework. This homework is harder than the other one. The first one was an easy one. This one, you need to be doing more stuff, and it's longer. So if you know you're not gonna have time, start looking at it right now, so that by Sunday you should be done. But guys, study, because things are gonna pick up very fast in the weeks to come. So for the next 2 weeks, we're gonna cover networking, and we're gonna go deep. Most of the things that I've already explained to you, Kingsley is going to touch on them and even go deeper. And then after that, Kingsley is going to come back to cover Active Directory, Windows Server Administration, domains, group policy,
Yep.
and some other fun stuff. And then after that, we'll be done. So by April, we'll be starting Linux, all things being equal. Okay.
So,
Yeah, go ahead.
please, I had a virtual machine, then I did IP-A to get the IP address. It gave me but the loopback address. I don't know what happened.
Because you did IP-A. You're supposed to do IP config.
Yeah, I understand. It's just taking us a little out of this the command line
It's
for
not
Windows.
-A, it's slash. It's
I'm not
slash A.
refusing. I'm not refusing.
Wait,
Is that a
first of
Linux
all,
machine or Windows?
hold on. That's the first question I wanted to ask. Like he did not specify the operating system. He just said
Yeah, I just said
run
a
this
virtual
command.
box. The virtual box that I asked us to download and be installing and continue. I tried to do an IP-A on that VM that I had
Yes,
installed.
but you haven't told us the operating system that you installed
What
Oh,
operating
on the
system are you
virtual box.
using?
That's what I'm saying.
okay.
Is it the
Because you have to have,
Windows
is it a
or is it
Yeah,
the
Windows
therefore it
Linux?
system?
was
Is it
Linux.
Unix?
Therefore it was. It's not for this class. It's for that other one. It's not for this class.
Okay.
No, yeah, it still doesn't matter if it was for another class.
It
We
will be
still answer the
mixing
question.
concept. Anyway, let me just bring it up. I was saying that I did IP-A, which is the standard. No, IP, then
So
space
first
A.
things first, Bismarck,
The
which
language.
operating system? You haven't still told us.
CentOS 7, OS 7.
Okay, so
Okay,
now you're
Linux.
talking about Linux.
Say
That's the
Yeah.
Linux,
Linux
don't say
system. So
CentOS.
that's the question
Oh,
we're asking. Yes.
okay. Well, instead talking about the flavor,
Yes,
Linux
CentOS
operating
is the
system
flavor.
of CentOS
Yeah.
flavor.
Just
Thank
say
you very
Linux.
much.
Linux is fine. Yeah.
Okay.
So
Right.
if you want to ask your question, say I was using a Linux operating system and I did you say it like this, IP-A. You don't say IP-A. That's the languages that you gotta use. IP-A to bring up the tech language, so you make somebody understands. Because you say something like IP-A, they understand that, oh, this person is probably an English student. It's not an IT student.
Okay.
So those are the difference.
Yeah, Bismarck, what were you trying to do? You were trying to look for the IP of the machine?
Yeah, the virtual machine. So it
Yeah,
gave me
you can just do the IF config, or you do the IPA or IP address show. There are lots of commands you can use
Yeah, to get the IP
bring up your
address.
IP address of a Linux machine.
yeah, but it gave me the loop address.
Yeah, you don't need to because you typed the wrong command.
That means
No, I typed the correct command, but it did when I gave. So now you're talking about that 127.0.0.1. So I'm trying to understand that that's
Okay,
that's the IP.
if you type
it's
IF
IF
config,
not IP
Yeah.
for
if
Linux
you do
machine.
IF config -A, or you do IP address show, or you do IPA, and that is the command that is supposed to show you your IP address. If you type that command and you don't get an IP, that tells you your machine is not connected to the network.
Yep.
It has no IP.
It has no network even.
It's not connected to the network. So that's where your networking skills should come into play. You start troubleshooting. Why is my machine not having an IP? Which is what I've been discussing with you guys in class last week.
And with virtual machine,
is your NIC enabled? That's the first thing you need to be. So
with
what you
virtual
need to do,
machine,
start troubleshooting. Use the machine and ping. Do a ping on Facebook. Do a ping on any IP, and see if you're gonna get a response. If you don't get a response, then traffic is not even flowing out of your network. Ping your default gateway, for example. If you ping your default gateway, you are not getting any response. It means you cannot even talk to your default gateway, which tells you traffic is not flowing out of your network, which tells you your machine is not connected to the internet. And if the machine doesn't have an IP, then the NIC is not enabled. So what you want to do is to go and enable your NIC. So DHCP can send you an IP address. But again, you haven't told us if DHCP was set for dynamic or static. We don't have that information. But I'm assuming it's dynamic.
Yeah. So and when you're doing virtual machine troubleshooting, it's quite different from you doing a physical troubleshooting, because anything you're doing on there is not physical. So you gotta be very careful what you're troubleshooting on. You might go turn off something, you might go disable something else instead of what you were looking for.
Yeah. Okay. Yeah, but it's straightforward. If he doesn't have an IP address, then the NIC is not enabled.
Yeah.
That's straightforward. Enable your NIC and you have an IP address.
My problem is where are they gonna find, where is the, you know where the NIC is located? I guess so, right? Bismarck.
Yes.
Okay.
Yeah, so since Bismarck is already ahead of the class, so you should.
Who else? Anybody have something?
I hope everyone downloaded all the softwares that we instructed you to download.
Yes, but the problem is to extract them from the zip folder.
What zip folder? There is no zip folder.
For instance,
anywhere.
the zip. For instance, the WinSCP comes with a zip.
No. Then
it's not
you're not downloading. You're not downloading the right thing.
PuTTY comes with a zip.
From where? Where are you getting where are you getting them from?
No, I don't know where you're downloading from, but they are not zip files.
That's right. There is one that's actually a zip file. I think it's WinSec. I extracted and installed it.
I think X mobile term is a zip file.
Yeah, it's a zip
that's
file.
The one that I know.
But it comes with it.
Yeah.
It comes with its extraction program on it automatically. Once you start installing it, its first thing is going to tell you to extract first. If you miss that step, that's why sometimes when you see those pop-ups, you have to read through before you just click. Except you've done something recurrently, that you just have to just click and go. But if it's the first time you're installing a program, you always want to try to read through, because you might go click something and it's saved somewhere that you cannot find it later on.
Yeah, but even if it's a zip file, when you try to install it, it's going to tell you it's a zip file extract, and you just click on extract and it's going to extract. You know, I think.
Okay, one last thing concerning the mobile XTEM cell. The mobile XTEM to do SSH connection to the VM, my own is not possible. I don't know why.
To do SSH connection to the VM, if it's not possible, then there are a number of things you need to start thinking about. Is SSH enabled on your VM? That's the first thing you should be worried about. So all these are troubleshooting steps. These are things that you encounter at work. You will try to SSH to machines and the SSH will fail. It is not the application. It can never be PORTY. It can never be X mobile term. That is the problem. Yep. It should be a server.
either the IP address
Yeah,
or
so
it might be.
first of all, go to another VM and try to use that VM and SSH to the VM you're trying to SSH to, or try to ping that VM if it's gonna respond. Right? If it responds, okay, try to SSH with the SSH command from one VM to that VM. If that SSH connection fails, then go check if SSH port 22 is open on the firewall, right? SSH is a protocol. SSH port is port 22. Is port 22 open on the firewall? If it's open, then that connection should go through. If it's not open on the firewall, the connection will fail any day, anytime, anyhow. So
port 22 is enabled, port 22 was enabled on the SSH because that is the port that listen to, yeah, the firewall. Okay, secondly, it is when I do the terminal login, it initializes like after 2-3 minutes, then they say unable to. So it is
unable to do what? Like when you
time out, the error message timed out. That is
what?
connection time out.
It cannot time out when you do a terminal login. It can time out if you do a porty, you log in from porty through SSH.
No, I'm talking mobile XM.
Mobile XM, the connection times out. But you said you are unable to connect through X mobile term.
Yes, I'm saying that that's the reason. That's the explanation. That's the reason I'm saying that, because I was not able to do terminal login. It means I was not able to use mobile XM and connect to the VM. That's what I maybe I should have written it in the IT way so you would have got it clearly.